What if shrinking to the size of an atom wasn't a superpower, but a death sentence? It sounds impossible. Yet hidden inside this idea is a mystery that completely changes how you see reality. Because the moment you begin shrinking, the world doesn't just get bigger. It becomes stranger. Imagine shrinking to 1 millimeter tall, small enough to stand beside a frog's egg. Sounds exciting, right? But suddenly insects become monsters. Every shadow hides a predator. Every raindrop feels like a falling boulder. So you shrink further. 10 micrometers. The size of an animal cell. Still not enough. 100 nanometers. The size of a virus. And this is where it gets weird. At that scale, your entire world becomes invisible to normal human senses. Objects you never noticed suddenly tower over you like mountains. But the ultimate challenge is still ahead. 1 angstrom. The size of an atom. Now the real question begins. Would shrinking this small unlock an incredible hidden universe? Or would it instantly destroy you? Most people assume size is the only thing that changes. But that's not even the craziest part. Your mass becomes a nightmare. If you somehow shrank without losing mass, every step would generate unimaginable pressure. The ground beneath your feet would experience crushing forces far beyond anything you encounter today. And that's only the beginning. The laws that quietly keep your body alive start behaving differently. Heat, breathing, energy, everything changes. What happens next changes everything. Because the deeper you shrink, the more reality starts breaking the rules you thought you understood. And somewhere beyond that boundary lies a world no human has ever experienced. But reaching it comes with a terrifying cost. As your body gets smaller, survival becomes a race against physics itself. At first, some changes seem helpful. Your lungs become tiny, yet oxygen becomes easier to absorb. Strange, right? Here's why. When objects shrink, surface area and volume don't scale equally. Suddenly your body becomes incredibly efficient at exchanging gases. Sounds like good news. But here's the strange part. Your metabolism goes into overdrive. The smaller you become, the faster you lose heat. To stay alive, your body would need a constant stream of energy. You wouldn't eat 3 meals a day. You'd practically eat nonstop. Every minute, every hour, every day. And that's still nowhere near the biggest problem. As you continue shrinking, the world starts fading away. Your eyes stop functioning normally. Light no longer behaves the way your brain expects. Colors disappear. Shapes blur. Darkness creeps in. Then comes the moment that flips everything upside down. An oxygen molecule, something you inhale without thinking, becomes larger than you. Think about that. A single oxygen molecule now towers over your entire existence like Mount Everest. Suddenly breathing isn't simple anymore. Suddenly movement isn't simple anymore. Suddenly nothing is simple anymore. And that's when a terrifying realization hits. You're trying to become smaller than the very building blocks that make you. But how do you shrink something made of atoms to the size of an atom? That question creates a paradox. A paradox that may make atomic shrinking impossible forever. And once you understand why, you'll never look at your own body the same way again. The greatest obstacle isn't surviving at atomic size. It's getting there in the first place. Every cell in your body is built from molecules. Every molecule is built from atoms. And your body contains more atoms than the number of visible stars in the universe. So what happens when you try to shrink them? Imagine a giant mosaic made from millions of tiny images. Remove a few pieces, and the picture still makes sense. Remove too many, and the image collapses into chaos. Your body works the same way. You might remove some atoms and preserve structure for a while. But eventually something critical disappears. DNA breaks. Cells fail. Life stops. And this is where the entire dream seems to end. Because the closer you get to atomic size, the less of you remains. But what if someone solved that impossible problem? What if you could somehow survive? Then you'd enter the most bizarre realm in existence. The quantum world. A place where particles appear in impossible locations. Where solid barriers can be crossed without breaking them. Where certainty vanishes. And probability becomes reality. You could tunnel through walls. Jump across impossible distances. Explore a hidden universe operating beneath everything you've ever known. But that's not even the craziest part. The quantum world isn't science fiction. It's already happening all around you right now. You just can't see it. Which leaves one final mystery. If reality becomes this strange at atomic scales, What other hidden worlds are waiting just beyond the limits of human perception? And what if we've been